Good afternoon. Thank you to be here in this session. We will begin. We will try to stay on time.
Come on, there is a
Does please.
seat here.
Then this class is about the new workflow for bridge design with InfraWorks, Inventor, Civil 3D in Revit. We could have called it also with the AEC collection. What we will see today in this session is then the new Autodesk workflow for bridge design. All the manipulations we will see are based on real data. It's an existing bridge we will talk about. And the goal of this session is to see together how to use the aero products then, that are in the AEC collection, InfraWorks, Civil 3D, Revit, Inventor, and ASBD, Autodesk Structural Bridge Design. On the right, you can see the different parts we will see together. First, the theory about the bridge workflow, some diagrams. Then the 8 steps we will show you about manipulation we can do on bridge with the different tools. And the last illustration will be the application of the same workflow for tunnel. These are illustrations of what we will see. On the left, the picture of this existing bridge, and on the right, the picture from screen capture from InfraWorks of the model we have created in InfraWorks using the data of the existing bridge.
So, hello everyone, I'm Stephane Balmain. I'm technical sales specialist. I'm based in Grenoble, so in France. I work for Autodesk since 10 years now. So I'm based on all structural workflow, so Revit, InfraWorks, Navisworks, BIM 360, and robot structural analysis. Of course, 10 years ago, it was more focused on Revit and robot than now, but I used to be product manager of robot in reinforced concrete. And before, I was in a structural office in Nice, SNC-Lavalin. And I have a blog in French-speaking language.
And I am Vincent Fredon, technical sales specialist for Autodesk, specialized in infrastructure. I'm based in Paris. I'm geotechnical engineer, and previously I worked more than 13 years in engineering companies as a road designer. I have also a blog, Civil Made in France. The data we used for this class, for this demonstration, are extract from a document called Declaration of Public Utility for a road project in the center of France, near Vichy, really center of France. You have the plan view of the main road project and the section of the road project. You see, it's a very classical road project with two lanes, very classical one. In this document, the Declaration of Public Utility, we found a plan view of one bridge, the biggest bridge of the project, the plan view and also the profile view. It's those two documents that we used a lot in our demonstration.
So we found in Plus a document from the precast manufacturer of the bridge, from Rector Lesage Group, so LB7. So they have done this bridge in precast.
Some two other pictures of the bridge to see better the object. You can go to the next slide.
Yeah. And we have chosen this bridge because it's not too complex and it's real. And in 1 hour, you will have all the workflow. There is other session done by Ara this morning where you can see a much more complex bridge done with this workflow.
Before the manipulation, the real manipulation with the tools, some explanation about the positioning of the different tools. First, InfraWorks, because the workflow we show today is based on InfraWorks and the interoperability of InfraWorks. As you know, InfraWorks is more and more powerful in the AEC collection. You have a specific link, very strong link between InfraWorks and Civil 3D. Bidirectional, you can import Civil 3D data in InfraWorks and you can open InfraWorks model in Civil 3D. We also have a very interesting link between Revit and InfraWorks, specifically for bridge and tunnel. We will see the demonstration. Something important to mention also is the new workflow to share topo surface between Civil 3D and Revit. It's called here share surface, and this workflow uses BIM 360. We will show you the demonstration. You have also the other tools at the bottom. 3ds Max if you need more advanced visualization. Navisworks. Navisworks, of course, is connected to all the other products, Civil 3D, Revit, but also InfraWorks. And we will use Inventor to create some specific models for InfraWorks. Why InfraWorks for bridge design? Because today, with InfraWorks, there is 3 words very important. Contextual model, parametric object, and dynamic model. That means that all what you will be able to create in InfraWorks is linked to a contextual 3D realistic model of the existing situation. You don't create the modelization floating in space like you can do in Revit, for example. All the 3D objects you use in InfraWorks are parametric objects. They are able to automatically adapt themselves to the situation, and you have a lot of parameters you can manage with this object. And all the model is dynamic. When you create your bridge, if you change the alignment or the profile of the road or of the rail, automatically the bridge will adapt to the update geometry, which is really important. You don't have to do anything. Then all the proposals you can do for bridge are based on existing technical rules by default in InfraWorks. You have the AASHTO, of course, but also Australian, British, Eurocode. Then the default proposition for a bridge in InfraWorks is already based on the technical rules you select for your bridge. Each time, at each step, you can ask for the main quantities of your bridge. This is also valuable for the earthworks, the networks. You don't have only bridge. The visualization, of course, is by default in InfraWorks. You don't have to do anything more to be able to share and to communicate on your proposition, on your technical proposition. For the documentation, we will use the link between InfraWorks and Revit to use all the advanced functionality of Revit to create the technical documentation. And for the construction staging, for the planification, we will use Navisworks, and we will import the model in Navisworks to use the timeliner in Navisworks to propose the planification.
Okay, so what will be our bridge workflow? So we will focus first on InfraWorks, linked to the PDF we have seen before. We will fine-tune elements with Inventor back to InfraWorks. Then we will send the terrain to Civil 3D, okay? And this terrain will be sent after with BIM 360 to Revit. And of course, here the bridge will be sent directly from InfraWorks to Revit. We have put here other link, because of course this is a new feature from this year. So of course you can link DWG and you can send through Navisworks in FBX the terrain and then send to NavisWorks format to Revit. Why there is this free line? So of course the best one is this one with BIM 360 because it's an exact terrain. Because if you go with DWG link or LandXML, it's the same. Revit understands only points, okay, and recreate the triangle. So it won't be the same terrain if you have rupture line, for example. So that's why in the past when we show this, we show both. Because in NavisWorks, it's not a real terrain, it's only 3D, but it's exactly the same. So to have both, sometimes it's nice. And once you are in Revit, with the terrain plus the bridge, of course, you will do all the documentation plus the rebar.
Okay, first part of the manipulation is the creation of the context in InfraWorks. And before, to work together with Stephane and I, as Stephane is based in Grenoble, you see here the point, this point. Stephane lives here. Oh, there's, yeah. It's not exactly this one. I live in Paris, Stephane lives in Grenoble. Then to work together on the same InfraWorks model, we used BIM 360. BIM 360 is the collaboration platform proposed by Autodesk, and InfraWorks is linked to BIM 360. You can propose a collaborative workflow with InfraWorks on BIM 360. The manipulation is really simple for InfraWorks. This is the BIM 360 user interface. I've used my project, my BIM 360 project that I use every day. I've created for this session a new folders to share with Stephane, and I've invited Stephane to work together on the specific folder for this session. The manipulation is really easy, and I've added to Stephane some specific authorization for him to be able to download the model and to edit the model. And with this tool, we are able to work together on one model in InfraWorks. The beginning to create the context is to use model builder. It's I would say that if you have some data to create the model, it's a good thing to begin with model builder, because you will have a first very good base to work. You could manage after, you could remove some data to add your data instead, but the model builder is really good thing to start to work with InfraWorks. Here I add the geolocalized area of my of the project. Then I've used it to ask to the geolocalization of the project, and you can see that I've asked to create the InfraWorks model linked to BIM 360 to be able to share with Stephane. Then automatically the master for my model, my InfraWorks model, is created in BIM 360. During this process, I received the email from the InfraWorks services telling me that the data are ready to be downloaded on my local machine to create the master, the context of the model. All the manipulation takes almost 4 or 5 minutes to get the master of the InfraWorks model. Okay? In this model, I have an issue with the topography. As we are working on an accurate model of an existing bridge, I need accurate topography. The topography from Model Builder is nice, but not accurate enough for me for this manipulation. The elevation of the model is not accurate enough for me. Then for that, to manage that, I will use the data from IGN, is the IGN, is the French official institution who can provide geographic data, and there is a free topographic base of topo then I will use to create another terrain, another topo surface with Civil 3D. It's the classic manipulation with Civil 3D. I create a new object surface, and to create the triangulation for this surface, I will use the topo, the data download from the IGN portal. I add a specific boundary to avoid to have a too large topography, and with this boundary, I'm sure to have exactly the same area for this topo than for the InfraWorks model. This is the triangulation created from the IGN data. We can check in 3D. And I'm sure that the elevation of this topography is more accurate than this from Model Builder. It's better for the modelization of the bridge. Second step here is to get something more accurate again for the specific area of the bridge. We have used the plan view found on internet in the document we have downloaded from internet. Then I will use this image, and to manage this image in Civil 3D, I've added to my Civil 3D raster design. With raster design, I'm able to import the image. It's a PDF. At the beginning, this image, it's a PDF. I import the image on Civil 3D. Of course, I'm not sure of the scale of this image. Then to adapt the size and the position of the image to my bridge, I've created the perimeter of the bridge from the aerial photography, the BIM photography in Civil 3D. And I use a specific functionality of raster design to adapt automatically the image to the specific 4 points, the extremities of the deck from the aerial image. This is an automatic process. You just have to say this point on the picture is this point in the reality on the aerial image. Then I will add some transparency to the picture. It's more comfortable to work, to see at the same time the aerial photo and the picture and the image. When the picture is at the right place, at the right scale, I Kogo points from the palette of Civil 3D, and manually I add the elevation I can read on the image, the PDF image. When I've created all the Kogo points from the image, I create another surface, another little topography surface specific around the bridge. And this topography is more accurate than the main one. The last manipulation is just to merge the main topography from the IGN data and the little topography around the bridge from the picture, the PDF picture. Then I create another surface, and this surface is the copy-paste of the two first surfaces. The result is this. I have a main surface for all the model, and for the specific location of the bridge, I have some little triangles more accurate than the main model. I just need now to import this specific topography in my InfraWorks model. It's very simple manipulation. In the data sources, just drag and drop the DWG file, the Civil 3D file. Automatically, the content of the Civil 3D file is recognized by InfraWorks and is in the data sources. I just need the last one, the last surface, then I delete the two first surfaces. I delete also the first one, the surface proposed by the model builder. And now I have all my model with the aerial image, all the roads, the rail, etc., but with my topography. This is what I wanted to get to be sure to propose the right bridge model. To check, here we can display the triangle in InfraWorks, and you can see on the right that right top we have the first proposition from Model Builder, and at the right bottom you see that the triangles are different and are more small, just around the position of the bridge. The manipulation here, there's not all the detail, you just have the visualization of the result. To get something more better for the visualization, I've just worked to replace the basic roads provided by Model Builder by the component roads, more advanced objects in InfraWorks. And with those objects, I'm able to adapt the geometry, the plan geometry, the alignment, and also the profile to get something more realistic in the model. I use what Model Builder proposes, but there's a little work to get something more realistic. I've also created a rail style to get something more realistic also. And in this phase, I've created the first proposition for the bridge. It's not shown here in the video, but it's the very basic, first basic manipulation when you want to work on a bridge. You just select a road and use the technical module of InfraWorks for bridge, and you just ask for the beginning station, the start station, the end station of the bridge, and InfraWorks propose a default model of a bridge. In 3 clicks with your mouse, you have a bridge.
So now we will move to this design of the bridge. So at first, we have had a classic bridge, okay? So we have put the TIFF picture on the terrain with the terrain overlay feature in InfraWorks. We just take care that to have the good coordinate, as you can see, in InfraWorks, and the same as in the TIFF. So after, what we will do, we will fine-tune the start and end session to have the correct total length, of course the number of piers, each span length, and after the size and number of columns of the pier and the foundation. So here, I look at the global value, so I will fine-tune the start. So of course, you can copy-paste from Excel. So now I have the correct total span, and after each segment, I will put the value. I change the value of each, same for each one. So it's always from the start, so that's why there is an Excel. And once I've done that, I will fine-tune my PL caps and the column piers.
When the bridge is exactly the same size and the same number of piers from the document we found on internet, from the plan view and the profile view, I just managed all the road components for the road profile on the bridge. And for that, I just selected each component and managed the right station for each component. Just drag and drop each component for the sidewalk, for each lane. For the transition, it's automatically managed by InfraWorks. Just tell to InfraWorks what is the new station for the beginning and for the end of each part of the road, and the transition are automatically managed by InfraWorks. I just finished by the rail guard to finish the modelization of the bridge.
So now I will customize my bridge. So if I look at the gridders, it was not existing in InfraWorks in the box. So I will select one existing, the closest, I can say, and I will update it in Inventor and save another name. And then I will come back to InfraWorks. So here, so I take iGriders, and so you can view on the element. And after I delete what is not needed, I recreate the section I need. I change the units. And here there is a slab will come at this point. So I create void. After I set my parameters, like this. And after I use infrastructure part shape utilities to save back in the correct format to be loaded in InfraWorks. So some tips to have more big value of dips so you can see it better in when you come back in InfraWorks to see. Or here it's easy because there are only 4 parameters, but if you have more, it's better to have a better picture. So here I load back, I say picture, it's a bridge, it's a grider. I say all my types, for example, 2 types of this bridge. And after the parameter, I can group them to separate them to easily modify them. And after I move my H2 bridge to this BIM. So I will apply to all the grider in every span. Like this. And after you can see, I have the reservation for the slab precast. So here, just one slide to explain the workflow you have seen, and it was very useful in PDF. So
we did the same manipulation for the cornices to the bridge because the real model is like that. First, it's almost the same workflow than Stephane has just presented. We use a 3D model, a 3D parametric model created in Inventor, added in the InfraWorks library. The first positioning is this model. Then I use the parameters to modify the position, the rotation, the elevation of this object because, of course, it's not at the right place. This is in the palette on the right. And I will change the model. As Stephane said, when you import a 3D model from Inventor in InfraWorks, you can set different precise for each model. And here, I've created a specific size specifically for this bridge to have a better adaptation of this cornice, this model, to this bridge. And when everything is setting correctly, I just have to manage the number of objects along the bridge to get the final rendering, correct rendering on the bridge.
So, of course, since we take an existing bridge, we know the size of the bridge. But here we will imagine which size will you choose using InfraWorks and structural bridge design. So what we will do at first, we will use only InfraWorks and the cloud of InfraWorks, which is structural bridge design, but you don't have any option in it. And after you will download, so you will have some key result from this. So you have global ratio and, for example, maximum banding, something like that, but not all detail. After, you can download all the details, so you can download the PDF reports. And after, what we will do, we will download locally the structural bridge design file, and we will fine-tune this analysis. So in my case, I will add a military convoy, and I will add a fluage model, I think. So here, so you select, you try to run the analysis. So here, everything is green, so everything is fine. You have to mind that this ratio is two-step because you have the reinforcement, and after structural design the reinforcement in it and the pre-stress reinforcement. So when you have only 0.7, it's really slow. So I can look at all the bending moment and the capacity curve, and I decide it's a little bit too strong, so I can change my beam to a smaller beam here. So I move from type 4 to type 2 for every graders. Okay, run the analysis again, and when it's from a different color here, you see, it means that it's close to the limit I have choose. Okay, so here if you look, it's look like it's fine. Okay, but let's have another. So here I move to type 1, as you can see, and here in type 1 it's above 1. Okay, so but 1.02. So maybe I can add a little more reinforcement or tendons and make it work. So I can look at every detail to see if it's accurate or not. Here. So I will summarize. So here I have my free analysis in the cloud. So here, since I don't have the military convoy and my advanced analysis, I choose the type 2 for next element. So what I will do, I will download locally the structural redesign file. So here. And after, so here I can check and set everything. So here you have all the span. Here you have all the material. Okay. So if you wonder what calculation is done in structural redesign, you can have a look here or in the calculation notes. And here, when I look everything, I will set here in the element new live load envelope. So here military. So here you see you have all kind of elements in highway or in rail, and I will have a fatigue model free. I have to rerun, and I tune a little bit the dead loads I was here, and after I will reload again the live load envelope. Okay. So when I've done this, after I will back this to my bridge, to my beam, sorry. Here, so I have the load created automatically. And here I transfer back to the beam. Okay. So now in plus, I have this action. And so I can look at the results here in sharing and in deflection and in support. You have all the results you need. And after, I will look at what have been existing. And maybe I can fine-tune my tendon. So I have the tendon optimization. So I have to select a group of loads. And here after, you see it's automatic. It tries every position of the tendon. Of course, I can do it manually if I directly see with the curve what has changed. But I want you to show something that structural redesign can help you. And after, I can look at every result with the new reinforcement and new tendon selected. Here, you can see it's updates according to what I select. So here, what I've done, I have done a military load and fatigue model free and optimization again. If you want to know more about this, there is an IKN article, so an Autodesk Knowledge Network article with a lot of tutorial in it. And you can do line beam analysis, but you can do grillage too, and finite element if you want. So let's move to communication.
Thank you, Stephane. The next step is working on the model to have something more usable to communicate and to share. There are just 4 screen capture directly from InfraWorks. You see that it's all the user interface. We are able to add a lot of details, some gabions. You can manage the roads, the shoulders. You can add rail guards if you want to be more accurate. Other way to present is to create some videos, some animation. It's very easy to do in InfraWorks. To create the animation, you just have to select an alignment, a road, a component, road, and automatically InfraWorks creates the video as a driver will see the project. Here I've done the manipulation on two different roads in the project. And after you can add vegetation, trees, anything you want to present something very clear that everybody can understand, technical, but also the public, not technical guys. Next step is about excavation. We will do a focus on the excavation needed to create this bridge. First manipulation is directly in InfraWorks. With the tool Land Areas in InfraWorks, you are able to simulate excavation. With the tool, you create as a platform, and this platform, this form, it's like a polyline. You can manage the elevation just using the gizmo here, the little grip, and I go below the ground just until I am below the foundation. The result is this one. And I'm also able to manage the slope for the land areas object just by selecting different preset slopes in the InfraWorks library. I'm also able to create my own slope for cut and fill in InfraWorks. I can also ask for the result, for the cut and fill value in square meter for this model. And here is the first approach of the excavation needed for this foundation. As you have seen, we are very close to the river. This could be an issue for this manipulation, for this foundation. Then I will try to optimize this excavation still in InfraWorks. Then for that, some different solutions. First is to propose some higher slope for the same excavation, and I try also to reduce the size of the excavation to avoid as possible the river. It's not easy, but I can propose some modification to keep the river as possible. Next step, still working on the excavation, is, for example, in InfraWorks to go deeper using the same tools to check how it's possible to organize the works. It's not here the staging, but it's more about how the site could be organized, where I can create the access to each foundation to create the earthworks with or without the bridge. I just, for here, of course, when you do the excavation, the bridge doesn't exist. Then you can select the bridge and ask to InfraWorks to not display the bridge for this presentation. It's also for communication, publication, to show how the things could happen for the project. If I need more detail for this excavation, I will use Civil 3D. As Civil 3D is linked to InfraWorks, I'm able to open from an empty Civil 3D file my InfraWorks model. Be careful to the coordinate system. For this manipulation, you need to have the same coordinate system in Civil 3D and in InfraWorks. The manipulation will not work if you have not the same system. You select the data you need from InfraWorks. You don't have to import everything. Here, what I wanted is the bridge, of course. This is the InfraWorks bridge in Civil 3D. And the specific surface created by my manipulation when I asked to InfraWorks to modelize the excavation. You can see here, you see the access to the excavation, and you see the shape I've created in InfraWorks. Based on those data imported from InfraWorks, I will create a more accurate excavation like this, with a very almost vertical slope for the river side to try to keep the river, to don't touch the river, and very slow slope here to access to the excavation. It's a Civil 3D manipulation. First, I adapt the Civil 3D drawing. I check that I have the data I need. It's just the bridge to get, of course, the foundation, the shape of the foundation. And I will work not from what I've done in InfraWorks. It was possible, but here I prefer to start again. After the first analysis in InfraWorks, I know now exactly what I need to do with Civil 3D. And I create a feature line using the shape of the foundation from InfraWorks. From this feature line, very easy to manage in Civil 3D. It's like a 3D polyline, but with more properties, more easy to manage than a 3D polyline. From this feature line, I will create the shape of the excavation, and it's the base for the grading creation in Civil 3D. All the gradings will be created from this line. I, of course, move the point to get something larger, of course, than the foundation. Very easy to do with Civil 3D. You can manage very precisely the size of this shape. And I add the gradings all around this shape. For the river side, I will select very high value for the gradings, for the slope here, almost vertical. You see that when you are in plan view, you don't see almost anything, but in 3D, you see that you have something very almost vertical. And for the other side of the excavation, I will do the same manipulation, but with a very, very low slope. I manage some distance between the two slopes because I will ask to Civil 3D to manage for me the transition. It's an automatic functionality available in Civil 3D for the gradings. You just have to select a place between two gradings along the feature line, and Civil 3D automatically create the transition. And the shape for the excavation is done. You see much more accurate than what I can do in InfraWorks. Okay, we can check in 3D that it's more detailed, and it's exactly what I want. The next step is to create 3D solids from this shape for the next manipulation. when you have minimum 2 surfaces in Civil 3D, of course you can have the volume, the detailed volume between the 2 surfaces with the dashboard volume in Civil 3D. It's very quick and very easy to use. And I will ask also to Civil 3D to create between those 2 surfaces, the ground and the surface extracted from the gradings, from the excavation. I want to create a 3D solid, this object. It's a different object than the gradings, but it's exactly the same shape. I will add a specific property to this 3D solid is the volume, of course. If I want to get this attribute, the volume in Navisworks, in InfraWorks, all those products where I can import those objects, those 3D solids, it's very important to get always the volume for each 3D solids. For this manipulation, I use a tool you have in the AutoCAD. It's basic 3D AutoCAD manipulation. With this tool, you can slice a 3D solid according to a plan. Then I've managed the plan according different elevation. And for each elevation, I've asked to AutoCAD 3D, to cut the solids. And I have different slices with this manipulation. I have 4 different 3D solids from the original one. Okay? It's to be more accurate. It's more realistic when you create the excavation. You don't do the excavation on one time. You do it by different depth in the ground.
Okay. So once you have done that, you will do the documentation and the rebar documentation with Revit. So first, you will send the terrain from Civil 3D to Revit.
It's me again. Thank you. Then this is the new functionality available since the 2019 releases for Civil 3D and Revit. And the goal here is to take a surface, any surface, of course, here is the terrain, from Civil 3D and to publish this surface in BIM 360 to be able to use it from Revit. The new functionality is in the ribbon collaboration in Civil 3D. You select the folder where you want to publish this surface. For this manipulation, you need the desktop connector installed on your machine. And you can see that on BIM 360, you will find this specific object, the surface, only the surface. And you can use the BIM 360 viewer to check the object published on BIM 360. You can see it exactly the topography, the surface from Civil 3D. And now this surface is available for Revit.
And you get the Rupture line, so exactly the same. So what I will do, of course, I will send the free bridge, because if you look carefully, here there is one main bridge and 2 other bridges in the past. I will add the terrain, and after I will link the 2 bridges in my first bridge. So very easy, right-click, send to Revit. So I will choose the template, the location. So of course, it's a little bit faster than in Rail. After I will link through BIM 360 my terrain, here. And when I've done this, so you can have a look, I will do the same for the 2 other bridge. I will keep the same folder here. So another bridge. If I try to acquire, it's the same coordinate. And here, so I will link by share coordinates the 2 other bridge, this one, and you see bottom one here. So now I will focus on first bridge, but before there was some change in the bridge, and I want my Revit file to be updated. So I've created some basic Revit file, but now I need to update because we want to be a little bit away from the river because my impact study asked me, for example. So I move P3 and P4 from 1 meters. Here. So after I will send, but this time I won't send new, I will update existing. So I put what I've done, it's easy. When I come back to Revit, I will have the note to explain what I've done. Because if it's not the same, we do both, it will be a little bit easier to understand. So here, you see. And what is nice, you will see after, I have put some tag annotation, and it will be update, okay? Because it's same component who have moved. So I could have put on face or something, or level, it will be update, okay? So if you have started your shop drawing, it's fine, it will be update. When I've done this, I will do a more detailed shop drawing in Revit. So I will move all the bridge. First, I've done a cut along an axis, but here I will move the bridge, and I will create group selection according to what have been created in Revit automatically. So here, because there is category, but you can't manage this category with the classic view option. So it's better to create groups, and after you manage these groups with filters. So here I've created all the category, and here you can see every element I need, and the BIM. Here I remove the graders. So here it's basic, but it's nice, and after I have the element, and for example here on this plan view, if I don't want to see my graders, I can remove them easily. And here, if, for example, I want to add some tag, I can tag easily the element. Here, same bottom. So it's a classic Revit functionality. Copy paste, choose the size on the plan. After you can bring 3D view with like the eye. And after you have classic cut, you can do, or more with a 3D element, and you can put some information on it if needed. And you have the same for the abutment, for example. Once you have done this, you will reinforce. Now I will put some additional, because I see it's missing here. So here it's done for the formwork. Here. And after, I will do some rebar. So I won't rebar all the bridge because we won't be there for only 2 minutes, but a little bit more. I will bar some part to explain. So there is 2 big workflow. One, a freeform rebar, you can select what you want by in 3D, or this kind of rebar. So here, the abutment is quite regular, so I chose the classic rebar, but I could have done with another. And here after, I can choose the number of rebar I add. Once I've done this, I will tag, of course, this rebar. So there is 2 tags, tag classic, and there is a multi-rebar tag here. And after you can choose the type you want, and you can put the tag. And of course, I will process for every part of the abutment and create classic shop drawing. 2D view you used to do in the past with AutoCAD or something else. And of course, you can add a 3D view, and in this 3D view, you can add filters by diameters or by numbers to see a little bit better the reinforcement. And same for the P4 with the column and the pier and the peel cap. Okay. Here you can see. So here I think I choose a color by number. And same for the top. And of course, when you have this, it's after you have directly the list of rebar, you can see below. And I filtered here to have only, of course, P4. Okay, I've created some groups. I could have created groups only for peel caps, only for caps, you know, to have more detail and to have the global weight. So, yeah, what I don't show you live, but you can do, it's you can move in Revit for a view the rear rebar. So to explain how you will build it, which is quite nice. So once you've done this, you can do clash in Navisworks, clash between rebars or with some other element to see if everything is fine.
Okay, construction planning. Last step, we have used Navisworks and the timeliner, and we have created a very, very simple simulation using importing in Navisworks different objects created in our workflow. The bridge, of course, but also all the different slices of the ground to simulate the excavation and the different steps for the excavation. And according to the different elements, you can create in Navisworks some task, or you create directly in Navisworks, or you use other tools like Primavera or MS Project to create the task and to link your timeliner to those tools, and after you link the task to the object in Navisworks. Okay, this is not specific to this workflow; it's something existing since a long time in Navisworks, but you can apply it to this workflow. And to finish this presentation, all that we have presented for bridges is also possible for tunnels in InfraWorks. You can create bridge, but you can also create tunnel. The section of the tunnel can also be modified, created using Inventor. If you need some specific section for your tunnel, you have a library in InfraWorks with some default section for tunnel, but you can, with default parameters, then you can do a lot of different things with the basic section in InfraWorks, but you can create also your own section with Inventor to modelize in InfraWorks your specific tunnel. This is the end for this presentation. Now, if you have, we have still little time. If you have some question, of course, we will try to answer you. And please don't forget to rate the session on the app for the Autodesk University app. Thank you very much.
Especially if you like it.